screen?
Yes, sir. Yes, sir.
Okay. So in the previous class, we were discussing the four types of feedback amplifiers. See, voltage series feedback, current series, voltage shunt, current shunt. Okay, the four types of feedback we were discussing. So the terms that we have here are voltage, okay, current. Here, first place, either it is voltage or current. Okay, then second place, right? Second place, either it is series or shunt. Okay. So what we have in voltage series feedback is, okay, output is voltage sample and connected in series at the input side. Okay, output is voltage sample. Output is voltage sample. Okay, and connected in series at the input side. Here, output is current, right? Connected in series at the input side. Now remember, any series connection, it is voltage. Okay. So here, first case, what is happening? Output is voltage. Okay, and connected in series at the input side. So series connection also represents voltage. Whereas in the second case, output we have to represent in the form of current, whereas series mixing represents voltage. Okay. In second case, in current series feedback amplifier case, we represent the output in terms of current, whereas input we represent in terms of voltage. Okay. Third case, voltage shunt feedback. In this feedback amplifier, output is voltage. Okay, clear, right? And it is shunt mixed at the input. A portion of output, okay, is connected in shunt at the input. Okay, whenever shunt connection at the input represents current mixing. So third case, we represent output in terms of voltage and then input in terms of current. Fourth one, current shunt feedback amplifier. Okay, output is current. Okay, so output is current and it is mixed in shunt at the input side. Okay, so output we represent in terms of current and shunt is, okay, shunt mixing is again the current mixing. Okay, so both input and output we represent in terms of current. Okay, so again remember voltage series. Okay, the first term voltage represents the type of sampling we are taking at the output. Okay, whether it is voltage sampling, then it is, okay, if it is voltage sampling and series mixing, then it is voltage series feedback amplifier. Okay, first term represents the type of sampling at the output. Okay, the second term represents the kind of mixing at the input. Okay, feedback is from output to input, isn't it? So this is what is the okay, what is the connection that we have at the output is represented by the first term, the first word. The second word represents, okay, the second word represents the type of mixing that we are giving at the input side, okay, as a result of feedback. Okay, then let us discuss the voltage series feedback amplifier. So this is the block diagram for voltage series feedback amplifier, right? This is voltage amplifier block with gain capital A. Then this is the feedback network, right? The gain of feedback network we will represent it as beta. Okay. Output voltage V0, RL, load resistor. Okay. Vi is input to the amplifier block. Vs is the input to the overall, okay, input to the overall feedback amplifier. Vs is the input to the overall feedback amplifier. Then AV, okay, this is the gain of this block, okay, gain of this block alone is V0 by Vi, okay. Then the feedback factor beta T. Beta will be simply what is its output divided by what is its input. Output of beta is, see, beta signal, feedback signal is coming from output like this. Okay. So what is the input to beta? Anybody can answer? The feedback we are taking, we are connecting from here to here. Can anybody answer what is the input to beta? Okay. V naught. Okay. V naught. See, this is V naught. V naught is directly connected as input to beta. Okay. What is the output to beta? Anybody can answer? Output to beta, easy question. Yes. VF. Okay. VF, the feedback signal is the output, okay, to the beta network. So beta is nothing but its output divided by input. So beta is VF by V naught. So beta is equals to VF by V naught. Okay. Vi is input voltage, V naught is output voltage, Vf is feedback voltage. Okay. So here we know, okay, we know this that Vi, okay, Vi for negative feedback is Vs minus Vf. Okay, Vi for negative feedback is Vs minus Vf. Okay. So next, the we already discussed that AB is V naught by Vi. So from this we can write this relation which is V naught is equals to AB Vi. Okay. AB is equals to V naught by Vi. So we can write V naught is equals to AB into Vi. Okay. Next, Vi, we discuss that for negative feedback, okay, case, right? See, by default, this entire unit, if nothing is mentioned, we will consider negative feedback, okay? So negative feedback, Vi, we can write it as Vs minus Vf, okay? This we discussed many times in the previous classes. So, V naught, we can write it V naught as it is, AB as it is, in place of Vi, we are writing Vs minus Vf. Okay. Next, multiplying this inside, we know feedback signal is beta into V naught. Okay. Feedback signal Vf is beta multiplied by V naught. Okay. So we are replacing Vf with beta V naught. Okay. Now we have V naught term here. We have V naught term here. Let's get all the V naught terms on one side. So this, okay, minus AB beta V naught. Let me take it to the LHS. So this V naught as this minus AB beta V naught becomes plus AB beta V naught. Then on RHS, AB BS as it is. Now here in LHS, let's take V naught common. If you take V naught common, 1 plus AB beta, okay, is equals to RHS as it is, AB BS, okay. Now let us, okay, get the relation, okay, V naught by Vs. Let us get the relation V naught by Vs. So V naught by Vs from this, okay, from this V naught by Vs will be Vs we will cross multiply to LHS 1 plus AB beta we will cross multiply to RHS. So V naught by Vs will be AB by 1 plus, okay, AB here as it is. When we cross multiply this, the RHS comes to the denominator, okay. So V naught by Vs from this will be AB by 1 plus AB beta, okay. And V naught by Vs is nothing but the gain with feedback, okay, voltage gain with feedback. So what did we observe? For voltage series feedback, the gain, okay, reduces by a factor of 1 plus AB beta. Next, input and output resistances. Okay. Input resistance is VI by II, whereas input resistance with feedback is VS by II. Okay. Resistance with feedback is VS by II. Okay. Now, Ri, okay, input resistance is VI by II. That as it is we are taking, and again we know that, okay, we are considering negative feedback, so vi we can write it as Vs minus Vs, okay. So next Vf, okay, Vf feedback voltage is nothing but beta into V naught, okay. Feedback voltage is nothing but beta into Vf is nothing but beta into V naught. So Ri as it is, Vs, okay, as it is. In place of Vf, we are writing beta V naught II as it is, okay. Next, let us multiply this II to the LHS. So Ri into II, the remaining Vs minus beta V naught as it is. Okay. Now here, okay, V naught, we can write it as, we already discussed that V naught, we can write it as, okay, AV into VI. V naught we can write it as AV into VI, and VI we can write it as II into RI. Okay. So first we are writing V naught in terms of VI. V naught is equals to AV into VI. VI we can write it as VI we can write it as II into R. Okay. So from these two, we can write V naught is equals to AV into II RI. Okay. V naught is AV VI. VI is II into RI. Okay. So you can write, okay, V naught is equals to AV II RI. So, so in place of V naught, we can write AV II RI. Okay. So in this relation, RI as it is, VS as it is, minus beta as it is. In place of V naught, we are writing AV, okay, AV II RI. Right? Now, here, why we are doing this? Because IIRI, IIRI, we can take common. So first, let us send this to LHS. Then RIII, if we take common, 1 plus A beta. Okay. Here RIII, right? So when we send this here, what will remain? Okay, this is minus, so it becomes plus. So RIII plus beta AB again IIRI. So IIRI, if we take common, IIRI if we take common, okay, here 1, then here AB beta, okay, so 1 AB, okay, then here VS, right? So now we can, let us cross multiply this II to the RHS. So VS by II, we are getting this. Okay. So what we are doing here actually is we are starting with RI. Okay, we are starting with RI and we are finding VS by II. VS by II is nothing but input resistance with feedback. Okay. VS, if you consider VS, then it is RIF. Okay. So in this manner, where this we can directly take it as RIF. Okay, directly we can take it as RIF. So we are getting a relation RIF is RI into 1 plus A beta. Okay. So what is happening? Input impedance is increased by a factor of 1 plus AB beta for voltage series feedback. Next, output resistance. What is the method for finding output resistance? What are the rules for finding output resistance? Anybody can answer? What are the rules for finding output resistance? Yes, same old rules that we discussed in first unit. Open circuit RL. Okay, make Vs 0. Connect an external voltage source. That voltage source value divided by current drawn by the output terminals. Okay, will give, okay, this voltage divided by current drawn from the, okay, output terminals. The voltage by current gives the output resistance. So the same rules they are mentioned here. So here let us once again see the circuit. Okay, so this is the circuit. Okay, this is the circuit. Now for finding output resistance, okay, for finding output resistance, RL open circuit, then Vs 0, then connecting a voltage source. V naught. Current drawn means towards left. Okay, current drawn by the circuit. Right. So now I naught we should take towards left. For see general case I naught we are taking flowing towards right. Okay, but only for the case of finding output resistance, we will consider the current, okay, entering, because it is current drawn by the circuit. So now we have to take V naught as, okay, V naught as current in leftward direction. Okay, in leftward direction. That we should call it as I naught. Okay, so V naught will be I naught R naught plus AV VI. Okay, so here V naught will be I naught into R naught. I said we should now consider I naught towards left. Okay, the only if first unit, second unit, okay, any unit it is the same. Only for finding the output resistance, okay, we will take I naught in this. Remaining for general analysis, I naught we will take, okay, clockwise. Only for finding output resistance, we will take I naught, okay, flowing right towards left. So that's it. I hope you observed in first unit also. Okay, anyway. So we are finding output resistance. So V naught current in leftward direction. We have to consider. I naught now we should take in, okay, this direction. So V naught is equals to I naught R naught plus AV. V naught is equals to I naught R naught plus AV. Okay. Next, Vi is equals to Vs minus Vf. Okay. Vi is equals to Vs minus Vf. But Vs we have to make 0, isn't it? So Vi is equals to 0 minus Vf. So directly you can write in place of Vi minus Vf. Okay. For finding output resistance, we should make source voltage 0, isn't it? So actually Vi is Vs minus Vf, but Vs is 0. So simply we can take Vi as minus Vf. Okay. So next Vf we can write it as beta V naught. Okay. For voltage series feedback, right? For voltage series feedback, we can write Vf as beta V naught. So Vf we are writing beta V naught. Next V naught terms, here there is one V naught term. Here let us bring the V naught terms together. So minus AV beta V naught, I will send it to LHS. So this V naught as it is, minus AV beta V naught, if we send it, it becomes plus AV beta V naught. Okay. So V naught, we can now take common V naught into 1 plus AV beta is equals to I naught R naught. Okay. So from this, let us cross multiply this I naught here, 1 plus AV beta to the other side. So V naught by I naught will be R naught by 1 plus AV beta. V naught by I naught is nothing but R naught F. Okay. R naught F is R naught by 1 plus AV beta. So the output impedance is decreased by a factor of 1 plus AV beta for the case of voltage series feedback. Okay. Voltage series feedback we completed, but let us observe few interesting things here. Here, okay, in voltage series feedback, See, whenever voltage series, okay, the title voltage series, voltage, okay, sampling, then series mixing. See, whenever you are mixing in series, okay, it means that the feedback signal is represented in terms of voltage. So the good thing with voltage series feedback is everything is in terms of voltage. Okay, everything. The output is voltage. Okay, the feedback signal is also voltage, right? That is the reason it was, we could easily take, okay, the relation, the calculation of the voltage gain was easy. Okay, but whereas for the next it is not so. Okay, so before we discuss current series, once again let us see the circuit diagram for voltage series feedback. Okay, right. So because voltage series feedback, everything we can represent in terms of voltage. Output is voltage, input is also voltage. Okay, output is voltage, right? Voltage series, output is voltage. Series means simply remember voltage. Okay, so input also voltage. Output voltage, input is also voltage. Then, okay, that is the reason in the circuit, okay, that is the reason in the circuit that we considered, okay, we are representing output voltage, okay, then input also we are representing in terms of voltage. Additionally, the feedback signal we are showing here. Okay, additionally, the feedback signal we are showing here. See, for now, to avoid confusion, we are neglecting this source resistance. Okay, we are neglecting the source resistance. And then, okay, the feedback signal we are representing it here. Okay, so this is our general amplifier Ri, AVBI, R0. Okay, Ri, AVBI, R0. RL is the load, Vs is the source, Vf is the feedback signal. Okay, and this is how we construct our circuit. Okay, this is how we construct our circuit for voltage series feedback. Okay, voltage, because it is voltage, right? Voltage series feedback. First term voltage. So output we are representing like this in terms of voltage, right? General amplifier is sufficient. Ri, AVBI or not. Okay. Then series mixing is voltage I told. So feedback signal is now, okay, voltage, right? So we are representing it as Vf, okay, and Vf in this case is beta P. Okay, same old case, Vf is beta. Okay, so if nothing is asked, simply they will say find out input and output resistance, voltage gain, okay, of feedback amplifier. Nothing is mentioned. By default, you can do it for voltage series feedback. If nothing is mentioned, simply if they ask, find out the input resistance, output resistance, voltage gain of a feedback amplifier. Generally, they didn't mention. You can do it for voltage series feedback amplifier. Okay, so next we will discuss is current series feedback. Now, first term I told you represents output. So output is in terms of current, right? Output is in terms of current. Series mixing means voltage. Okay, now the feedback is voltage. Okay, right? And input side we have to represent in terms of voltage. So output is current, input is voltage. Okay. So now which amplifier we should consider? Output current, input voltage means, okay, four amplifiers we discussed, isn't it? Okay. We discussed four amplifiers, right? Voltage amplifier, current amplifier, trans conductance amplifier, trans resistance amplifier. Okay, four amplifiers we discussed. Okay, discussed four